This is Xenofeed, news of the outworld.
What greater mysteries face a sentient being during their brief existence than the origin of their own life? And what, if anything, lies beyond their ultimate demise? What are we? Why and how are we capable of even pondering such questions? What is it about us that allows us to perceive the world around us, to feel the warmth of the sun upon our face, and experience a coincidental sense of joy? To feel the bitter sting of loss in the wake of a loved one's passing, or to experience the deep wonder of the night as the Milky Way blazes across a moonless sky? Is the ability to consciously experience and be aware of these deep feelings the culmination of elegant biochemical processes resulting from hundreds of millions of years of biological evolution taking place inside of our brains? Or is there something more? To date, no one has been able to arrive at a chemical formula or a biomolecular pathway to explain the phenomenon of consciousness. To be fair, some argue, and rightfully so, that no aspect of consciousness cannot be associated with a biological process. This is true. To our knowledge, only living things display consciousness or sentience, although with the emergence of artificial intelligence, this may soon no longer be the case. Nonetheless, it would seem that biology and consciousness are inseparable. Whether synthetic mechanisms can or ever will attain true sentience is a matter of conjecture. It has been reasonably argued that the dynamic interaction of appropriately arranged molecules in living systems is the key to understanding the phenomenology of consciousness. From this perspective, consciousness is not only derived from biological processes, but from the conscious functionality born of the appropriate spatial arrangement and proximity of essential biological components. Complex though they are, most if not all biological processes are the result of chemical interactions that are either duplicable in vitro or discernible in situ or in vivo. The primary chemical elements involved in all biological processes here on Earth are carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. There are also some 19 other trace elements found in living systems that are used primarily as enzyme cofactors in processes like DNA replication. These include potassium, calcium, sodium, magnesium, iron, zinc, and selenium, to name a few. All of these elements, and indeed all the elements in the known universe, including the elements that make up our physical bodies, were formed in the interior of exploding supernova in a process known as nucleosynthesis. The process of manufacturing heavier and heavier elements within the interior of a star begins with the synthesis of helium from the fusion of atoms of hydrogen. This is the process taking place inside our sun right now. The process of fusion continues for billions of years until the hydrogen fuel that powers the engine begins to deplete. Eventually, as its hydrogen fuel is expended, gravitational forces within the star begin to increase exponentially as the star shrinks and grows denser and denser. When the hydrogen is completely expended, the fusion of helium begins. Helium fuses to form carbon. Then carbon is fused to form oxygen, oxygen to neon, neon to silicon, and iron. Finally, if it is sufficiently massive, the star collapses in a final death throe known as a supernova, and it is in this moment that it spews forth its heaviest elements like gold, uranium, and neptunium. Here on Earth, elements on the periodic table numbered above 93 have all been artificially created in high-energy particle accelerators and colliders, such as the CERN Large Hadron Collider near Geneva. A single atom with one proton, one neutron, and one electron. The simplest and most abundant element in the visible universe arose, as did all matter, from a singular, infinitesimally small, immeasurably hot, infinitely dense singularity, magnitude smaller even than a single atom of hydrogen. All matter, everything we are, everything we know and love, arose from an infinitely small space that preceded what we call the Big Bang. What then can be said of consciousness? What is it? Did it develop over eons of time along with the increasingly complex web of biochemical pathways that evolved within the living things that eventually began to occupy the cosmos? Or was consciousness present at the inception of creation? Was it present in that infinitesimally small kernel of nascent pre-universal protomatter? Is consciousness in fact an inherent property of matter, or even a fundamental property of the universe itself? This is the central query that underlies all modern cosmology. The view that everything is conscious, and that consciousness is a fundamental and ubiquitous feature of nature, is known as panpsychism. The Greek philosopher Thales of Miletus, who is also said to have been the first to predict a total eclipse of the sun, is credited with being the first to ascribe consciousness to matter. He regarded life as being inseparable from matter and posited that even plants, as living things, have immortal souls. He believed that the divine, or what we would call consciousness, that is, the ability to be conscious, was itself a fundamental element of nature whose presence was necessary to animate all the other elements. We are then, relative to evaluating the nature and import of our own existence, faced with a profound question. Is consciousness contained within the physical confines of the brain, or is it non-local? Does it extend beyond the physical confines of the brain? Is there any evidence at all that consciousness is more than a resultant phenomenon of biological evolution? Atoms, as we know, are singular entities comprised of a nucleus, which is made up of a certain number of protons and neutrons, surrounded by a cloud of electrons. The electrons are found in a cloud of discrete valence orbits that vary in distance from the central nucleus depending on the element. The number of neutrons in the nucleus gives the element its atomic number. It is the arrangement of the electrons in their valence orbits and their attendant electromagnetic forces that allow singular atoms of any given element to react to and interact with atoms of other elements, to form larger structures called molecules, and ultimately to form all known substances, including the proteins, minerals, and trace elements from which the tissues of our physical bodies are constructed. According to the standard model of particle physics, as we peer further into the atom, we see that the components of atoms include even smaller, more bizarre particles called quarks, leptons, and bosons. Beyond the subatomic particles described by the standard model lie the strings. It is the harmonies created by the vibration of these strings that give rise to our shared reality. Einstein could not wrap his head around certain aspects of quantum mechanics. Einstein's problem with quantum mechanics was, in essence, that realities in the quantum world could only be reduced to mathematical probabilities. Subatomic particles did not follow the hard and fast rules of celestial mechanics. For example, one can determine the location of a subatomic particle but cannot simultaneously measure its velocity. Conversely, one may measure the velocity of a subatomic particle, but may not simultaneously establish its precise location. This is known as the Heisenberg uncertainty principle, and it reveals the deeply uncertain nature of matter itself. Subatomic particles have a dual nature. That is, they behave as both particles and waves. Far from being the indivisible atomos proposed by the Greek atomists, the basic building blocks of nature described by the Standard Model have no true substance. They only become solid when their wave functions collapse upon external observation. This perplexing phenomenon is illustrated by the classic thought experiment known as Schrödinger's cat. In the experiment, a living cat is placed inside a sealed box along with a vial of poison and a radioactive source. If an external radiation detector detects any radiation, that is, the decay of one atom, the vial of poison is broken and the cat dies. The Copenhagen interpretation of quantum mechanics tells us that after a time, the cat in the box is simultaneously both alive and dead. It is only when the box is opened that one reality or the other can be observed. Observation of the cat, by opening the lid, causes the collapse of this quantum superposition of eigenstates into one reality. The cat is observed to be either alive or dead, not both at the same time. This is known as quantum wave function collapse. The wave functions of all quantum probabilities, that is, the cumulative probabilities associated with the superposition of all subatomic particles, collapse upon external conscious observation. Rather than being separate and independent, consciousness and reality appear to be dependent upon one another. It is in the explanation of this phenomenon that strictly chemical, biological theories appear to fail. The ultimate conundrum for Einstein manifested itself in the form of quantum entanglement, or what he referred to as spooky action at a distance, or spukhafte Fernwirkung. Quantum entanglement is a phenomenon of quantum mechanics wherein elementary particles become associated with other elementary particles in such a way that their quantum states cannot be separately described, but must be described together as part of a combined system or eigenstate. When particles of these systems are measured, their measurement affects the state of their associated particles, no matter the distance between them. Einstein and others believed this could be explained by certain local causality factors, but they were at a complete loss to explain what precisely those local factors might be. How could the observation of one particle instantaneously affect the quantum state of another particle, even when light years distant? This form of communication would seem to violate the universal speed limit, or the speed of light. This glaring incongruity came to be known as the Einstein-Podolsky-Rosen or EPR paradox. A potential solution to the EPR paradox was proposed by John S. Bell in what has come to be known as Bell's theorem. Bell's solution contemplated the existence of non-local factors and directly challenged Einstein's theory of local causality. In 1964, Bell published a paper in which he was able to demonstrate that no theory which satisfies certain assumed local conditions, as proposed by Einstein, could fully account for the quantum probabilities for the predicted outcomes of experiments. He was able to derive mathematical formulas that conflicted with actual experimental measurements, demonstrating that quantum mechanics is non-local, such that communications do not weaken over great distances and take place instantaneously. Put simply, local causality factors as proposed by Einstein cannot fully explain the high correlation between the quantum states of the particles. Something else was happening, something that, once discerned, would forever alter our basic understanding of the universe. In 1981, Elaine Aspect conducted a series of now famous experiments that proved Bell's theorem. The experiments Aspect and his colleagues conducted involved measuring the correlation between the atomic spins of paired photons. In the experiments, paired photons were derived from excited calcium atoms. The paired photons were then separated by lasers and measured by detectors at varying distances after separation. The result of the experiment was that there was such a high degree of correlation between the spins of the paired photons that any attribution to so-called local causality factors could be conclusively ruled out. Einstein had been wrong. The universe was not deterministic, and dice was God's favorite game. Like space and time, consciousness and matter are inseparable. Matter does not become matter until it is consciously observed. The universe we observe collectively represents the continual cumulative collapse of the wave functions of all elementary particles under direct observation, coupled with the collapse of the wave functions of all those elementary particles with which the observed particles are inexorably entangled. This would necessarily include every particle in the known universe. In a recent article published in the Journal of Astroparticle Physics, authors Dmitry Podolsky, Andrei Parvinsky, and Robert Lanza demonstrate a physical basis upon which the reality we experience may be the result of a conscious network created by our collective consciousness. This new theory of consciousness is called biocentrism. Somewhat similar to the theory of panpsychism, biocentrism posits that life, as the source of consciousness, creates reality. None of us creates our shared reality alone. Rather, the reality we experience is created by our collective consciousness, such that it is not wholly dependent upon any single personality. We could take it a step further and simply say that the universe is comprised of one conscious mind, and we are all a part of it. The apparent physical separation between us is nothing more than an illusion. These theories are far from proven and fraught with considerable complication. Panpsychism in particular is dogged by two particular problems, that of combination and dissolution. If, as panpsychism suggests, consciousness is present in the most elementary particles, then precisely how do these elementary particles combine to create consciousness? Some have proposed that it is a matter of material coalescence. However, if it was merely the fact of particles coming together to form matter, then would not that make a rock conscious? Is all matter in all its forms therefore conscious? Should we not be able to carry on a conversation with a bicycle? If consciousness is present in the most fundamental of particles, would it not be possible then, under the appropriate circumstances, to artificially produce consciousness, or indications of such, from simple materials? Complementarily, what explains the dissolution of consciousness? How and why does it degrade? One might think of these discussions as a never-ending quarrel between those who see the glass as half empty versus those who see it as half full. Are we not greater than the sum of our parts? Despite being addressed by the most educated and intellectually gifted of our species, the question remains unanswered. Despite the obvious challenges presented by the theories of panpsychism and biocentrism, There is a substantial, growing body of empirical evidence to suggest that rather than being isolated to the brain, consciousness extends beyond it, not only spatially, but temporally. One such repository of evidence may be found in the mounting mass of data being collected by Princeton University in conjunction with the Institute of Noetic Sciences in something called the Global Consciousness Project. This data appears to prove a rather marked effect of collective human consciousness on the operation of random number generators. The Global Consciousness Project employs a global network of random number generators in over 60 host countries. Based on the phenomenon of quantum tunneling, these random number generators constantly produce and record purely random sequences of zeros and ones. Researchers at the Global Consciousness Project hypothesized that the Global Consciousness Project's network of random number generators will show anomalous deviations that are associated with globally perceived events when there is extensive participation in or reaction to such an event. To test this hypothesis, they review the data collected from the random number generators for a period of time before, during, and after a global event that affects large numbers of people. The hypothesis is that if consciousness has no effect on the random number generators, then there should be no statistical deviation in the number of zeros and ones being randomly generated during globally perceived events. Statistically speaking, over any given period of time, there should be roughly 50% zeros and 50% ones. However, if consciousness does affect the random number generators, then it stands to reason that there would be a significant statistical deviation from the expected values over the same period of time. The results of their ongoing 15-year study are astonishing. One of the most statistically significant of the events studied by the Global Consciousness Project was the nearly simultaneous bombing of the American embassies in Nairobi, Kenya, and Tanzania on August 7, 1998. 224 people were killed. Reviewing the data collected for a 3-hour period immediately following the bombing showed significant statistical deviation from the results. Likewise, the events of September 11, 2001 gave rise to a statistically significant deviation from expected results over 20 hours, with the highest deviation occurring at precisely the time of the events. These statistical anomalies cannot be explained by any known mechanism of physics. The fact that there is a significant statistical deviation, i.e. a subtle structuring of the data that coincides with the event, characterized by a gradual yet immediate rise and fall in the range of statistical anomalies before and after the event, strongly suggests a collective conscious awareness that not only coincides with any given event, but that precedes and follows it. Ergo, collective consciousness appears to be unbound by either space or time, and to a certain extent can be predictive. This would tend to make sense, since space and time are in fact indistinguishable. The Global Consciousness Project has tracked this effect around more than 500 global events. Astonishingly, their estimates show a less than 1 in 1 trillion chance that the effect is due to chance. Princeton University's involvement in these types of studies is not new. The data being produced on a global level by the GCP confirms the findings of earlier smaller-scale studies conducted at Princeton School of Engineering and Applied Science, or PEAR labs, related to the effect of consciousness on random number generators. In 1988, Brenda J. Dunn, Roger D. Nelson, and Robert G. Hahn produced a paper on studies they conducted that showed a statistically significant effect of human intention on a random mechanical cascade device. This RMC employed the use of 9,000 polystyrene balls which were dropped vertically through a matrix of pegs that scattered the balls randomly into 19 separate bins. human operators were asked to attempt to shift the balls to one side or the other, left or right, using only their mental acuity. Of the 25 human operators chosen, 4 showed anomalous separations. 2, however, demonstrated significant right or left separation, entirely depending on their intent. These studies are ongoing and too numerous to examine in detail. Suffice it to say that there is accumulating, reliable, repeatable data proving these consciousness effects. The truth is that as conscious living entities, we are intimately connected to one another. The separation between us, physical and spiritual, is an illusion. We must confront the reality not only that we are connected to each other, but that we are a part and product of nature, not external observers of it. We are a conscious part of the universe. We create it together and exist within it. As conscious living entities, we provide the physical senses through which the universe perceives and contemplates itself. Consciousness, whether it exists in the most elementary of particles, in some other as yet to be discovered form of proto-consciousness, or perhaps in the form of a field, appears by some miracle to be ubiquitous in nature. That the elements of the periodic table interact in the infinite ways that they do speaks of a deeper hidden truth that cannot simply be explained by the random machinations of time. The image that emerges from our examinations is an infinite tapestry whose beauty defies description, intricately woven from the reality we all share. It spans the known universe and reaches into the deepest corners of our personal experiences. Ultimately, one could argue that if consciousness is indeed shared and creates our reality together, then the only thing of true value any of us has to offer is love. One could also argue that if there was room in that infinitely tiny speck of protomatter that preceded the Big Bang for everything that ever was or will be, then surely there is room in our hearts for one another.
Thank you for watching Xenofeed, News of the Outworld. If you enjoyed this video, please remember to like, share and subscribe. Click the bell to be notified when Xenofeed posts new, thought-provoking content. Xenofeed.